Let's go to part 2. Solve for x on the design domain. For a, 4 sine x cubed equals 3 sine x. X is greater than negative 2 pi less than 0. We know this is a polynomial pattern equation. So first of all, we need to get equal 0 form. Move 3 sine x to the left side. We get 4 sine x cubed minus 3 sine x equals 0. Common factor is a sine x. So we have 4 sine square x minus 3 equals 0. So we get the sine x equals 0. And 4 sine square x minus 3 equals 0. Let's solve sine x equals 0. We have a diagram like this. Let's label this diagram by given domain. 0, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. We know the coordinates are CST. Sine x equals 0. We want to get the second coordinate is 0. So this is a sine x equals 0, sine x equals 0. Since the given domain x greater than negative 2 pi less than 0, this 0 and negative 2 pi are not in the domain. Therefore, we only have one solution, x equals negative pi. Then let's solve 4 sine square x minus 3 equals 0. This is a power pattern equation. We need to isolate the sine square x first. You will get sine square x equals 3 over 4. Square root both sides. You got sine x equals plus or minus square root of 3 over 2. Since sine x equals positive and a negative square root of 3 over 2, it will go to all 4 quadrants. Reference angle is 60 degrees. That is pi over 3. From this 0, go this way. Then stop at negative 2 pi. In the fourth quadrant, that is negative pi over n. The third quadrant is negative n plus 1 pi over n. For the second quadrant, it is a negative n minus 1 pi over n. For the first quadrant, that is negative 2n plus 1 pi over n. Therefore, the solution will be x equals negative pi over 3, negative 2 pi over 3, negative 4 pi over 3, and negative 5 pi over 3. So altogether, you have 5 solutions. Negative pi over 3, negative 2 pi over 3, negative 4 pi over 3, negative 5 pi over 3. Let's go to B. Cosine 2x minus 1 equals sine 2x. X is greater than 0, less than 4 pi. This is a trig equation with a double angle. Look at the double angle formula. We have cosine 2x equals 2 cosine square x minus 1, or equals 1 minus 2 sine square x, or equals cosine square x minus sine square x. For sine 2x equals 2 sine x cosine x. No doubt for this sine 2x, we can write down 2 sine x cosine x. How to change this cosine 2x? You need to consider this minus 1. We do know from first formula, we have cosine 2x plus 1 equals 2 cosine square x. From second formula, we can get 1 minus cosine 2x equals 2 sine square x. Here, we have cosine 2x minus 1. We put the negative sign to the both sides for this equation. You will get cosine 2x minus 1 equals negative 2 sine square x. So for double angle formula, you really need to remember this formula and this formula. So we can get negative 2 sine square x equals 2 sine x cosine x. We count this is a quadratic pattern equation. So move to the right side. You will get 2 sine x cosine x plus 2 sine square x equals 0. Common factor is 2 sine x. We get cosine x plus sine x equals 0. Then we can set up 2 sine x equals 0 or cosine x plus sine x equals 0. Let's solve this equation. Divided by 2 both sides, we can get sine x equals 0. This x is a quadrantal angles. Therefore, let's draw quadrantal angles coordinates. Given domain is x greater than 0 less than 4 pi. Let's label. Sine x equals 0 is here. Therefore, we can only label these two angles, 0, pi, 2 pi, 3 pi, 4 pi. Since x greater than 0 less than 4 pi, which means this 0 and 4 pi are not in the domain. So we have 3 solutions. X equals pi, 3 pi, 2 pi. Let's solve cosine x plus sine x equals 0. Move this one over here. You will get cosine x equals negative sine x. Divided by cosine x both sides, you will get 1 equals negative tangent x. Isolate the tangent x, you will get the tangent x equals negative 1. Tangent x equals negative 1. Let's draw another diagram. 1, 2, 3, 4. All students take calculus. So we know tangent x equals -1 go to second and fourth quadrant. Let's label this domain on this diagram: 0, pi, 2 pi, 3 pi, 4 pi. Get started from 0, ending at 4 pi. We only need to label second and fourth quadrant. For second quadrant, you have n minus 1 pi over n, 3n minus 1 pi over n. For fourth quadrant, you have 2n minus 1 pi over n. Then we have 4n minus 1 pi over n. Let's check the reference angle. It's a 45 degree equals pi over 4. Therefore, x equals, we plug in this formula, n equals 4. So you have 3 pi over 4, 11 pi over 4, 7 pi over 4, and 15 pi over 4. Altogether, for this equation, we have 7 solutions. Let's go to say 3 sine square x plus 5 cosine x equals negative cosine square x. X is greater than negative 4 pi, less than 3 pi. Because we have 5 cosine x, you need to change sine square x into cosine square x. Remember, the sine square x equals 1 minus cosine square x, and a cosine square x equals 1 minus sine square x. Therefore, you will get 3, 1 minus cosine square x plus 5 cosine x equals negative cosine square x. Distributive property: 3 minus 3 cosine square x plus 5 cosine x equals negative cosine square x. You could say this is a quadratic pattern equation. Therefore, we move everything to the right side because we want to make the coefficient of cosine square x positive. Since you move everything to the right side, we get 0 equals 3 cosine square x minus cosine square x minus 5 cosine x minus 3. Combine like terms: 2 cosine square x minus 5 cosine x minus 3. This is 0. Let's do ninja x. 2 times negative 3, that's negative 6. This is negative 5 over 2 over 2. Negative 6, we can do 1 times negative 6. This will be the factored pair we are looking for, because 1 plus negative 6 equals negative 5. So you have 1. This is negative 6. Reduce, you will get negative 3 over 1. Then the variable is cosine x. So we get 0 equals 2 cosine x plus 1, cosine x minus 3. Then we need to solve the following two equations. 2 cosine x plus 1 equals 0. cosine x minus 3 equals 0. For this one, you will get the cosine x equals 3. No solution. Because the range for cosine x is from -1 to 1. Let's solve this one. Cosine x equals -1/2. Let's draw a diagram. So we know cosine x is a negative. We'll go to second and a third quadrant. Let's check domain. X greater than -4 pi, less than 3 pi. Let's do positive first, from 0. This is a pi, 2 pi, 3 pi. We start from 0, stop at 3 pi. For negative, this is a 0. Then you have negative pi, negative 2 pi, negative 3 pi, negative 4 pi. We stop at negative 4 pi. We only need to write the pattern for second and then the third quadrant. For second quadrant, you have n minus 1 pi over n, 3n minus 1 pi over n, negative n minus 1 pi over n, negative 3n minus 1 pi over n. For third quadrant, you will have n plus 1 pi over n, negative n plus 1 pi over n, negative 3n plus 1 pi over n. Since 3 pi stop at second quadrant, so there's no 3n plus 1 pi over n as the pattern. The reference angle equals 60 degrees. That is pi over 3. Therefore, n equals 3. So we use this pattern, write down solution, altogether 7 solutions. This will be the solutions to this equation. Let's go to question D. 2 sine x equals tangent x. X greater than negative pi over 2, less than pi over 2. For tangent x, we will change into sine x over cosine x. Then we will do cross multiply. You will get 2 sine x cosine x equals sine x. We count sine x cosine x as a quadratic pattern equation. So try to get equal 0 first. 2 sine x cosine x minus sine x equals 0. Sine x is common factor. 2 cosine x minus 1 equals 0. So you have sine x equals 0, or 2 cosine x minus 1 equals 0. We will get cosine x equals 1 over 2. For sine x equals 0, this is a quadrant angle. Let's draw diagram first. We know the coordinates are CST. For sine x equals 0, is these two angles. Therefore, let's label. We have to label according to the given domain. X greater than negative pi over 2, less than pi over 2. Positive angle first, from 0 to pi over 2. That's the first quadrant. Then from 0 to this negative pi over 2, it's the fourth quadrant. So you have first and then the fourth quadrant only. In other words, domain is only in the first and the fourth quadrant. So this x equals 0. For cosine x equals 1 over 2, positive. So we go to first and then the fourth quadrant. Pattern here is pi over n. This is negative pi over n. Reference angle is pi over 3, 60 degrees. Therefore, x equals negative pi over 3 and pi over 3. Altogether, we have 3 solutions to this equation.